Hello, Algebra 1 students. Today we're starting Chapter 10, which is the last kind of function that we have to talk about in order for our EOC to be what we expect. Today's lesson is just kind of an introduction to exponential functions. You've been introduced, but it's been 4 or 5 months since you have seen anything exponential, so I want to kind of ease you back into some of the subject matter. Now, looking at some different documents that I have, it looks like the EOC will have 6 questions out of 62 that have to do with exponential functions. So we're talking about a few questions here, so we need to make sure that we understand what's going on. Okay, so today we're just going to cover the basics. Here's the parent function. The parent function's formula is f of x equals a times b to the x power. So for example purposes, I went ahead and chose a b for us. So 2 to the x power would be a parent function. Anytime you just have a number raised to the x power, that's a parent exponential function. This number does not have to be the same for it to be the parent. If you have a parent function, it will always go through 0, 1. Now if we shift it up and down, which I'm going to show you a little bit later in the video, then your y-intercept will change a little bit. But I wanted to talk to you a little bit for a second about why this number is the same. So let's take our example 2 to the x power. So if I raise 2 to the 0 power, what do I get? 1. So for this x, I get this y. Okay, well let's change the base, because I told you it worked for any base, no matter what. So 5 to the 0 power, that's still 1. Okay, so that's why that works. No matter what number I use, if I raise it to the 0 power, it's still going to come through 0, 1, unless I do other things to that. Okay? So if you have a parent function, which all of these examples would be, then it goes through 0, 1. Okay? So you need to remember this equation and be very familiar with this graph and this point. One more thing. We'll talk more about this tomorrow, but there is something called an asymptote. And that is a line that this equation will come extremely close to, but it will never cross. In this case, your asymptote is y equals 0. Now, why is that important? Okay, so no matter how small of a number I make this, like if I made it 0.0000 negative infinity, even at negative infinity, it is not going to be 0. You cannot come up with a number, raise it to an exponent, and get 0 out of it. So it will never cross that line. This asymptote comes in handy a little bit later on, and we'll talk about that. Let's talk about continuous or discrete. So if I'm looking at a graph, and I'm just going to quick draw these, that would be continuous. It includes all these points, I don't skip any, and I have arrows on both ends. Now if I gave you something like this, that is discrete, because it has individual points. I don't care about anything in between it. So I need you to remember the difference between continuous and discrete. Works exactly the same as linear and quadratics. Also, if I give you a table, that is discrete data. Okay? Alright, let's talk about the domain and range. And I got to split this into 2 sections, so we'll start with continuous. That's the tough one. Well, if I could spell continuous, that would be helpful. So continuous data. So I have a graph or an equation that I could graph, and right now I'm just going to use f of x equals 2 to the x power. Okay, so that means that this will come in at 0, 1. Okay, so if it's continuous, my domain Well, I go off to the left forever, I go off to the right forever, and cover every point in between. It must be all real numbers. Or on the EOC, sometimes they'll write it as negative infinity is less than or equal to x is less than or equal to positive infinity. Your range works very tricky in this with exponentials, because it's never going to cross this line. Since we're using the same example as the parent function, I know that y equals 0 is an asymptote. I'm never going to touch or go below that line. So the way I'm going to say that is y will always be more than 0. And it will always be one less than the coordinate of your y-intercept. It's always down one step. Okay? Now, for discrete data, so let's say discrete data, all you have to do is list the x-coordinates for domain and list the y-coordinates for the range. And so I'm just going to give you an example. I'm not going to use this graph as an example, but if I had a nice graph to look at, it'd be like 1, 2, 3, however many x's there are, and then the range would be something like 1, 2, 3, something like that. That's what that looks like. Okay? So here's a few practice problems. So I want you to go ahead and answer this. Okay, was that continuous or discrete? This was continuous. What is the domain of this function? Okay, so the domain is all real numbers because it has a left arrow, continues going to the right, didn't skip anything, and we have an arrow on the right, so it has to be all real numbers. Continuous or discrete? Okay, so I told you anytime I give you individual points or a table, it has to be discrete. Okay? What is the domain of this? So all I have to do is list my x-coordinates. Easy one, right? There it is. That's my domain. What is the range of this function? All I have to do is list the y-coordinates because it's discrete data. There it is. What is the range of this problem? Okay, since I have an asymptote at y equals 3, I know that y has to always be greater than 3. Find the domain of this one in discrete. So what I would have to do on this one is I would put this in my calculator, pull up a table, and put in some points. So this one, if I chose 0, it would be 1. If I chose 1, it would be 2, 2. So put it in your calculator, get a table. And that concludes today's video. Please make sure that you have your name properly installed on this thing so that I can see that you did this. This will be for a grade. Thank you. Have a nice afternoon.